Assalamualaikum and hi everyone. This video is Form 4 KSM Part 1, Chapter 1, Quadratic Function and Equation in One Variable. Focus on 1.1, Quadratic Function and Equation. Our learning standard for this video: identify and describe the characteristic of quadratic expression in one variable. Quadratic function and equations. What is a quadratic expression in one variable? In general, the general form of a quadratic expression is ax squared plus bx plus c, where a, b, and c are constant and a is not equal to 0. X is a variable. For example, x squared plus 2x minus 1, negative y squared plus 3y, 1 over 3 m squared minus m plus 4, and 2n squared plus 5 are examples of quadratic expression in one variable. Have a look at example 1. Determine whether each of the following expressions is a quadratic expression in one variable. If not, justify your answer. Have a look at question A. 2x squared plus 5 is a quadratic expression in one variable. X cubed minus 6 is not a quadratic expression because the highest power of the variable x is 3. Quadratic expression, the highest power must be 2. Okay. For C, 3x squared plus 2y plus 1 is not a quadratic expression in one variable because there are two variables, which is x and y. 1 over 2m squared is a quadratic expression in one variable. 2x squared minus 3 over x squared is not a quadratic expression because there is a variable with a power which is not a whole number. 4x squared minus x to the power of 1 over 2 is not a quadratic expression because there is a variable with power which is not a whole number. Power here fraction. All quadratic expression can be written in the form of ax squared plus bx plus c, where a is not equal to 0. In a quadratic expression, a is the coefficient of x squared, b is the coefficient of x, c is a constant. Don't forget your homework, self-practice 1.1a. Next. Our second learning standard for this video: recognize quadratic function as many to one relation, hence describe the characteristics of quadratic function. What is the relationship between a quadratic function and many to one relation? What is the difference between a quadratic expression and a quadratic function? A quadratic expression is written in the form of ax squared plus bx plus c, whereas a quadratic function is written in the form of x equals to ax squared plus bx plus c. Can you spot the difference between expression and quadratic function? The quadratic expression has no equal sign, while quadratic function has equal sign here. All quadratic functions have the same image for two different objects. In general, the type of relation of a quadratic function is a many-to-one relation. For a graph of fx equals to ax squared plus bx plus c, where a is not equal to 0, there are only two shapes of the graph. The value of a determines the shape of the graph. If a greater than 0, then we will get a smile-shaped graph. While a is less than 0, we will get a sad-shaped graph. What is the maximum or minimum point of a quadratic function? Each sketch of the graph of quadratic function has the highest or lowest value of y-coordinate based on the shape of the sketch. For the sketch of the graph of a quadratic function with a less than 0, y1 is the highest value of y-coordinate and x1 is the corresponding value for y1. The point x1, y1 is known as the maximum point. Okay. For a set-shaped graph, this is a value of a less than 0. For set-shaped graph, we have a maximum point. For the sketch of graph of quadratic function with a greater than 0, there is a minimum point. So, there's two things you have to remember for a set-shaped graph, which is a less than 0, the value of a less than 0, we have the maximum point, while for a greater than 0, smile-shaped graph, we have a minimum point. For a quadratic function, fx equals to ax squared plus bx plus c, the maximum point is obtained when a less than 0. The minimum point is obtained when a greater than 0. What is the axis of symmetry of a graph of a quadratic function? The axis of symmetry of the graph of a quadratic function is a straight line that is parallel to the y-axis and divide the graph into two parts of the same size and shape. The axis of symmetry will pass through the maximum or minimum point of the graph of the function as shown in the diagram below. So the dotted blue line here is an axis of symmetry that passing through maximum point and minimum point, which is divide the graph into two parts with the same size and shape. The axis of symmetry of the graph of a quadratic function is parallel to the y-axis and passes through the maximum or minimum point. In general, each graph of quadratic function has one axis of symmetry which passes through the maximum or minimum point. So this is the axis of symmetry passing through minimum point. This is also an an axis of symmetry passing through maximum point. Okay, homework self-practice 1.1b. Okay, that's all for this video. See you in the next video. Thank you.